Hi, so this is another part of my tutorial series for autosplitters, and this one is gonna cover Unity games and signature scanning, pretty much nothing else, because the topic itself is very complicated anyway. So I'm gonna go just for that, and you're gonna need some additional tools, or just one tool honestly, and that's gonna be dnSpy, and that's pretty much it. And you also need some Unity game. I don't have any other Unity games available right now, so it's gonna be Lost for Darkness. Unfortunately, this game is banned on Twitch. I will not show any explicit parts of the game, so I hope this video doesn't get blocked in any way. It shouldn't, but anyway, I just need to warn you a bit. I don't need to start it just yet, or maybe I can actually. So I will open Cheat Engine and I'll show you one little interesting thing about Unity games. I will just open it, and you can see that when I open a Unity game, this mono pops up here, and you can activate the mono features, and this basically allows you to scan through the game in a bit better way. For example, if you do Dissect Mono, you will get a lot of files here, or parts of the game basically. Usually you use the assembly C#, but there might be some different ones, and you might find some interesting things here. Let's say we get door, doesn't have any static field, but that's fine. And you just do some things here. You can like see it in the memory, etc., and you see exactly where it starts. It's interesting. You can really. It's much easier to inspect games in Unity than it's in other engines, but it's not that easier to work with anyway. And a lot of you might have the idea that you can actually find something here, so you would do something like loading, let's say. You do find, and you might be thinking that you will find something useful. A lot of the time that's not the case. Sometimes it is the case, but it's hardly accessible, etc. So it found something. It found loading screen level name. Well, probably didn't find anything really useful, but there is some loading stuff anyway. And you cannot really get to it. You cannot really get to this. But you could get to this through a different method, like through this, but because you don't really see the code, you won't really get to it anyway. So I will close the game, and what I'm gonna do is I'm gonna open it in dnSpy. Close, please. Thank you. And I just click open, and when I get to the game directory, I go to some data. It will usually be like managed. There can be different ways for different games, but usually it's something like this. And I will open the assembly C#. Now, other files might be useful, but usually not those general ones. For example, like Unity Engine, etc., Unity Engine networking, those are usually useless. These are the framework ones, and they don't really work that well. So I will open this, and I can actually see what's inside. And here I can basically open all the classes in the game, and let's take a look. So you might find many things, and it might actually give you something very useful. So you just go through the names, and here I can see, for example, loading level, loading screen manager, scene manager, loading screen manager. These things are really useful. I will actually look at something just to make this a bit easier for me, because I forgot about something, so just give me a second. I just need to have this here because I just want to be sure I don't do something what I don't want to do. Anyway, that's it. Just had a little screenshot here. Anyway, so you go through this and you search for something that could be useful, and in this case we will be we will first focus on getting the load screen, like load removal. So let's take a look. We can take a look at the loading scene manager. We can just double click it and see how it looks. And I can also do the same for loading screen manager, because can I open both? Open a new tab. Oh, I opened the wrong one. So I'll open these two. Why is it still opening the same one? Okay. Now that works. So I have some that might actually make some sense. Usually managers are very consistent in finding, and they usually have some interesting values as well. So when I take a look at this, I can scroll down and see what values it handles. So it has like so it has things like the button text, some end time. This is really arbitrary value that doesn't really have any description, so I don't know what that is. Private bool, a load level that might be something useful, but we don't know where that activates anyway. There is hide loading, so this would be also maybe useful. Show button also might be useful, but this seems to be more of the UI part of this. So I know that the loading screen manager worked better, and if I look through this, I don't see any value that that could be useful, but there actually is a value that is useful. If I take a look at this, I believe there is no static instance. If I just do Ctrl F and type static, it's not gonna find anything. So this is a problem, because we need this to implement static in some way. And for example here, if I do static, it will find public static loading screen manager. Loading screen manager is what we are, is the class that holds these numbers, these values. Now this requires you to know a bit about C#, or generally just object-oriented programming. So it might be a bit hard to understand, but I'm sure it's a bit understandable if you just look at it. Basically every of those files is a class, and class handles some functions, or methods as we call them, and some values. That's probably all you need to know. And these static ones are what we can easily find in the memory, and if we have the one for loading screen manager, which we have here, then that means we can easily access all of these. So if we find the loading screen manager, we might get to any of these other things. So let's think what could be useful. This doesn't seem like a too good thing. These are just some texts. This is some load screen panel. Maybe load screen panel could be something useful. but it doesn't seem like it has something useful really. It has some load description, description ID, picture, loading level name, so that again seems to be some interface thing. So let's go back. This is some sprite that will be completely useless. Fonts controller doesn't seem too useful. This is list of those loading screen panels. We already know what loading screen panel looks like, so this is going to be completely useless. Some text. Usually this won't really be useful. Maybe the text might disappear during the load or something. Who knows? But it's a bit inconsistent to work with that. Text asset, that's again some text, so that won't probably help. Screen loader seems like it might be something useful, so I will open it. And let's see what it has in this class. So I'll scroll down, and it has some values. So let's take a look. It has quite many of them actually, so that's good. And it has something called finish load, and it's just a boolean, and boolean means a value of 0 or 1, or in other words, true or false, where 1 is true. So that seems like it might be useful. And this time we don't actually have to have the static in here anywhere. Maybe there actually is static. No, there is not. But it doesn't matter because we already have static in this. And we know that if we have static here, static instance of this load screen manager, we can get to all these values. And one of them is the load screen manager, scene loader. So when we get to the scene loader, we already have it from this one, so we can also access all of these values. So I believe what we are looking for is the finish load. So yeah. Anyway, what you can also do is make a bigger search. And that is doable if you do search assemblies, and let's say you're looking for something that can implement loading, so you do load, let's say, and we want it to be a field because that's a parameter, or that's the value, and we also probably want to here this will be a ticket by default. I usually recommend you to untick it because the framework assemblies are usually not useful. And when you find some load in the framework assemblies, they might like not work exactly, like they might work, but the load might not be the exact how you want it. So I would avoid them. And then you usually get a huge list, and you can kind of try to see what could be useful here and just go through this, and maybe you'll find something. And I'm pretty sure you will find the finish load here somewhere. Here, yeah. So yeah, but if you found it, you would actually just now you would if you would find this first, you would not be able to get to this because you don't have anything static to this. So you would have to look for where any BL scene loader is located, and through some research you would find it in the screen manager, and in the screen manager you would find the static. And for example, and this could take many levels. For example, if you found the screen loader here and this wouldn't have a static instance, then you would be looking for the loading screen manager in some other class until you reached some class that has static instance. So there was a lot of information about this, and now let's take a look how this works. So we have this instance, and we will need to see where it is created. So there are some data containers that makes no sense. And here we can see loading screen manager dot instance equals this. So this means that when the function awake is called, we actually set the instance to this class, or this instance of a class. So now when we know it's the awake function, we can actually start the game. I will keep the program running. And just to be sure, I'm gonna open a new game, because sometimes it might work a bit inconsistently, so I just want to be at least in the game to make sure that every of the values is loaded. So yeah, now we know it's in the awake function of the loading screen manager. We are now going to be looking for the instance. So what we do is we open the game in Cheat Engine. I don't think we have to activate the mono features if we use Dissect. I think, yeah, if you use Dissect, it will activate automatically. And then you go to this one, and we have opened the assembly C#, so we will open it here, and we will scroll down to loading screen manager. We can also search for it if we want to. It's up to us. So let's do loading screen manager. It has a static field. This one is important, but we cannot do anything about it. It has the scene loader, we can see it here, and we can actually see the offsets, and that will be very important. And here we can see the awake method, and that's the one we need. So I will right click it and do JIT. So now this will be a lot of gibberish to most of you, but I hope we can somehow get through this. Now you have to look at the code, and you can see like that some of these things will be in the code as well, or in this rather. So for example, here you can see cursor visible equals false, and here we can see some Unity Engine cursor set visible. So I assume that we are somewhere at this line. And let's go lower, set cursor, so this might be something like this. And locked state, that is somewhere here. I suppose that this entire thing is more complex than just setting the value. So this, for example, does many other things. So it goes probably to like, it probably covers this entire thing. And then we have the lock state, and we can again see that it's here. And then we have the loading screen manager instance equals this. So this means that to this some address is being assigned. So it would probably, the most sense would be that it's this one. Maybe it could be this one. Somewhere near this, it should probably be it. So yeah, you can actually see these addresses here. These could be like all useful. I'm gonna go with this one. I believe that's actually the one, and yeah, I believe that's the one. Now to get this, I will actually I need to actually explain you how this works. So we have you have to understand that the address is here and not here. Like it doesn't start exactly here at the start, it starts there. And this is all bytes and 2 letters or numbers represent 1 byte. So this is 1 byte, this is 2 bytes, this is 3 bytes, 4, 5. So we need to read the address, and how we do that is we can actually, well, we know that this is loading screen manager awake plus 50. The 50 is an offset, but it's hexadecimal. So this means this number is 80, I believe. And we need 81 because this is, when we use 50, we get to this, but this is not the address. We need 51 because this is 1 byte. So plus 1 gets us here on this. So that would be 51. But be aware that you have to use hex calculator. You need to learn how hexadecimal numbers work. So I will know that loading screen manager awake plus 51 will get me to this. I'll just take a look if it's correct. Yeah, it is. So I will create a pointer and I'll call it, because we are using the mono features, we can actually do this. So loading screen manager awake and plus 51. And as you can see, this points us to this address. So this is some pointer. So yeah, it reads this and gets us here. So now this is very important, and this will basically get us the instance. This is the instance of the load screen manager. And now, because we are in the instance of the load screen manager, we can access all of its fields. So the way we do that is we can just take the C and because this is also because we got a pointer, we got like after reading this address we got a pointer to the loading screen manager, but we need to read it again to actually get to the loading screen manager. So we add a 0 here, we keep it there, we add one more offset, and here I can see the C here, so I will add C. And this means I actually am on the scene loader. So now that I'm on the scene loader, I actually don't know how to get the other values that are inside of the scene loader, but because I actually am accessing it, I can find it here. So let's take a look if there's the BL screen loader. I mean scene loader. I cannot find it, so I will try to do find class BL scene loader, and it actually found the class. Finding class is also better than finding fields in this situation where I know it's a class, because otherwise it opens all of those files and it makes it really messy. So now that I know I have the scene loader, I will take a look at the fields because I'm already accessing it and I can just get it. So let's take a look if the finish load is here. Yeah, here. So I have the finish load here with offset B9. So now it couldn't be any more simple than just add B9. And of course it's a boolean, it actually even says here, and I will call it a byte. And we see that it's 1. So now I can close the mono dissector. I will still keep this here. And let's take a look. So I am in the game. Let's see. The value is called finish load, so now it's at 1, which means true. So I assume that now it's actually now Now it's actually like working right, because it tells me that the load has finished. I'll try to do some interaction. Seems like it's not changing. Yeah, seems normal. And let's do reload. When I entered load, it turned into 0. And now that I can continue after the load, it turned into 1. So after the load finished, it actually set to 1, to true. So this seems like it's working. Now, in some communities, you wouldn't want this to work like this. You would want this to still be removing loads. But for the simplicity, I will just go with this. And let's do one from the menu to see that it's actually working. Let's do new game. 0 right now, which is correct. Finished load, so it is true. So that seems like that's all correct, and we know that it's working. So in the auto splitter I'm using, there are 3 values that I use, and one is this finish load, then its level load name, and its running locker. I'm not going to be going through all of them, but I can kind of show you where they are. So if I do search assemblies, it's Ctrl+Shift+K. I'll do let's say the load level name, and you find it in the game manager, which is very very frequent in the games, in Unity games, to have a game manager, and it's usually static as well. Here we have a static address to it, so we would do the same process for this, and we would find the load level name, etc. And then we have the running locker. I suppose that will be some controller, yeah, first person controller. So this might be a bit more complex. I suppose this will not actually have anything static here. It has some static oh, actually, even the first person controller has a static instance. So these are the most simple situations with the game loader and game manager and the first person controller. These luckily are static and they contain the value that we need, so that's good. The one that we covered fully is the one that was the most complex one, the one which needed more offsets, because we first needed the loading screen manager, then we needed the BO scene loader, etc. So let's close this for a while. And now, how do we put that into ASL script? Now that's even more complicated. So far we didn't have to do any scans, but we know that we have this function. I can actually there should be some way to, where is it? Select current function. Yeah, this will select you all of those parts that belong to the function, and these we might use them for so-called signature scan, and signature scans are kind of a weird thing. So let's take a look. So if I do copy to clipboard, I have many ways to copy this. So I can do this one. This is a very complex one and it's kind of messy. We don't want that. I'll show you how all of them work. You might use what you find the easiest. This is the same thing but with comments, so it's even more messy. Then you can do just bytes, which is just the left part of it, and you can do opcodes, which is basically the same thing, except instead of the bytes you get opcodes. Then you have bytes only, so you don't get this column, which is kind of both messy and good. Then you can have the opcodes only, which is just this, and this is completely useless to you. So I recommend you to get honestly probably the bytes and opcodes or the bytes. Yeah, so because of the way it's aligned, so you know that these are going to be usually some addresses, the long ones, the ones that have 8 characters. They also can have 16 characters for 64-bit games, and all of these will be just very fluid. They will be changing a lot, they will be very volatile. So you just replace all of those 8 characters with question marks. Now, if I would do that, you need to do this manually, by the way. I haven't found any tool that can do this for you, not even in this thing, not in Cheat Engine. Maybe there is something that could surprise me, so definitely leave a comment if you know about something. And once you do that, you will be... So the reason why we do that is because we will have some kind of pattern like this, and it will be present in every launch of the game, but the addresses will be different. The addresses especially are basically non-static things. So all of the long ones will be different, and some of the other ones will also be different. So what I recommend is just experiment, and you'll see what works and what doesn't. There's really nothing to lose, because all you have to do is dissect mono, find the loading screen manager, and JIT awake, which takes like 30 seconds at most, and it's just because you're finding the loading screen manager in the list. So really getting to this point is not hard, and you just replace those things with question marks. You can also do a bit more drastic thing, which is just take the function, copy the bytes only, and have some tool that can compare strings. I will actually maybe provide you one at some point, because this is for those people who completely don't get what's going on. And if you would like get, like, let's say at least 2 computers, and let's be honest, it's kind of gonna be inconsistent, you can just add question marks to the long ones, because you know that those are always gonna be different, or most of the time. And then you can make like many launches of the game and just always copy the bytes, put them in some kind of processor, and where there will be collisions, the program would just replace it with question mark. So you can also do that manually if you want to. But anyway, how you find out that it actually works? So when you get your sequence, which might look something like this, let's say I will just remove, say we have that. Oh no, I want to copy that. Never mind, I will just do this. I will find D3 85 FB FF. So if I replace this with question marks, this one like this, Then I have a signature, and if I copy it, I can search for array of byte. I'll paste it here, and I do a scan, and I can actually see that it found just one result, and it is actually that. And once I remove more and more of these values by replacing them with question marks, I will get more limited results. Or like, this wouldn't work if I launch the game again. So you have to really remove a lot of things that could be non-static. In the end, after removing all those inconsistent things, this is how the actual thing looked. So there's a lot of question marks, it's really messy, and you have to just try and maybe it will work. So if I do new scan with that, first scan, it actually finds it, and that's the part we need. So if you want to know where this where this address is, if you do disassemble this memory region, we know that we get here. So that's what we need. And this is actually something that other splitters can actually check for. So we will do that. So I will just put it here. And really for this, for getting the signature, you just have to try. And you know that the long ones you can always remove or replace with question marks. And the other ones, they're a bit more complex, let's say. So it will be trial and error. So let's make a script. So I will get a new file, and I will call it, let's say, Lust for Darkness. Can I type normally? .asl. And now, because we are not going to use any values that we have a pointer to, we will just create a state with the exe name. So that's Lust for Darkness without version identifier. We don't need that. And it's gonna be just empty, so I can just do this. Or you can just leave it multi-line if you want to. Now on the startup, I will, and startup is when the script is loaded, I will create a scan target. So we create a var, custom one, that will be, let's call it just scan target. And it looks something like this: new sig scan target. Don't forget the semicolon. And here is some number. I will put 0 here for now. And here is the signature. So we just put it here, and that's just it. And now this number basically tells you how much it should, like, where it should read. So where it should like get. So now if we leave 0 here, it will just get to here. Now this is not a hex number, it is a decimal number, and we know that we need to get here. So that's 50 plus 1, that's the 51. So that's what we have essentially here, the 51. But we need to convert it to decimal number, which is 81. So 81, and this will allow us to read the part that we need. So now we will create init, which will work whenever we open the game, and we will create an int pointer, which is just integer pointer. Let's call it ptr, and first we will initialize it with 0, like this. This means that this basically means that the pointer is empty, and if it's empty, then we can just then we know that it didn't find anything. So now we will do something a bit tricky. So we will create a for each, and for each basically means that I will explain it. Memory pages, and something will happen here. Here, for each basically means that we have some structure that handles many things. I already explained for each in one of the tutorials. I will just remind you. We have memory pages. This means that this is like the full memory of the game, and it has like multiple pages. So we just take one page from the memory pages, we process it in some way, and after it's processed, it will get to the next page and over. So what do we do now? We will create a scanner. It can be just var because we don't need to use it later. And it will be signature scanner. And what goes into signature scanner is the game. This is always available. Game is always available, by the way. Then we get the page, which is here. You could name this anything you want. Just make sure that you name it the same here. And we get the base address. That means it will start scanning from the beginning, basically. And we will scan until the page ends, basically. So region, size. And it needs to convert to integer because it's not integer by default. So yeah, you can check documentation. Maybe this doesn't have documentation, so you would have to go through the code. So it would be a bit more difficult, but don't worry, you will not need to do anything more difficult than this. And so now, when we scan for this, so basically this just prepared the scanner. This just create a scanner that can scan through the memory. It can search something in the memory. So if the pointer is in pointer 0, which is what we did here. We basically said that the pointer is 0 now, and we are asking, is the pointer still 0? Well, we didn't do any scan yet, but we will do one just inside of it. So if the pointer is empty, we will change the pointer to whatever the scanner gives us when we use scan. And when we use scan, we have to enter the scan target. So we do vars scan target. And what this is gonna do is this creates the scanner that scans through this page, but because we are in for each, it scans through all the pages. It will scan from this place to this place. Okay, my neighbors just started drilling, so that's great. Never mind. Yeah, that's great. I might take a little break to just wait if they stop soon. If not, I'm gonna do mess and then I'll return and I hope it's fine. Anyway, let's give it up to 5 minutes and then I'll return. Let's give it 3 minutes actually. Let's not be that nice today. So be right back. I will tell you to return. Feel free to skip this part, of course. Okay, it seems like they stopped running, so I am back. Now they are using a hammer, but that's fine, that's not that loud. Let's continue. So this will create a scanner that will scan the game from this place of the page to this place of the page. That's a bit just theory, doesn't matter. And then we use the scanner to look for basically this and get to this location. So if it found something, it will put an address here into the pointer. If it didn't find anything, it will set it to in pointer 0. So that already works for us. So at the end of each of the for eaches, we can just check if the pointer is still 0. If the pointer is 0, then we can is not 0. If it's not 0, that means it found it. Then we can just break, and break will basically jump out of the for each and it will continue here. So this means the value was found in the memory, and we can just continue. We found the thing and that's all good. If it didn't find the thing, it will just go to the next page, do the scan again, and over and over until it finds the page. Now if it didn't find the page, now it would crash later, which is fine because we want it to reload. Because if the script crashes, it will actually just reload. So I will not be doing some infinite loop here, because that's not necessary. So yeah, so this part of the code finds the address, or finds pointer. So this part, oh, I'm sorry, I didn't realize this at first, but because I also have a bigger monitor right now, I will make this bigger for you. I'm sorry. I hope that's readable now. And here prepares scanner in all pages, let's say. If a pointer is still not found, scan for signature. If pointer is found, exit the loop. I hope that's understandable. And let's continue. So now we need to somehow watch the address, and for that we have memory watchers, and they are fairly simple. I will just show you how they work. So we create watchers. Again, all of these things like this, and this, all of them can be named as you wish, just use them in the code properly. So this will be a new memory watcher list, because we might have multiple of the watchers, so it's better to just have a memory watcher list. And I will actually show you that we will have multiple of them. And now we know that we have the pointer, but we only have the pointer to this area, to this part. Now that is great, but we need to actually read that value. So we know that we need to read 4 bytes, because we read 1, which is A8, B8 is second, 49 is third, and 06 is fourth. So this is 4 bytes. So that's the first thing. And second is, and also if it was a 64-bit address, it would be 8 bytes, so it would be longer. So what I'm gonna do here is I'm gonna create another pointer, and that is gonna be the pointer of the instance of the loading screen manager. So let's call it instance instance pointer, and first we read the memory, so we read the 4 bytes, and where we read it is we read it at the pointer place, at the place of the pointer, and we read 4 bytes. So this is the first thing. This reads 4 bytes for us. So we just get this. Now we need to convert this to 32-bit number. So that's int 32. Because we read bytes and int pointer is integer, so we need to convert this into int pointer. So we would think that this would be enough, but it's not, because this is still bytes and it cannot just do this. So we need to use bit converter, and it has 2 and 32. It also has 2 int 64 in case you were working with 64-bit address. So we just add it here, and at the end you have to add 0, because this means this basically means that it will convert the number from a different byte. So you would like convert from this byte, for example. We don't want that. We want to convert from the first byte, so that's why a 0 goes here. And then this whole number is integer 32, 32-bit integer, so we can convert it into int pointer. Same goes for if you had it 64, then you can convert it like this. But there would be 8 here, of course. If you did this here, or this here, this wouldn't change anything, but it wouldn't make sense, of course. You would read 100 bytes, and this would just take 4 of them anyway, but let's keep, like, it would work most of the time, unless you try to access some memory that's inaccessible. But let's put 4 here, because that's what makes sense. So now we add a memory watcher to the watcher list. So we take wars, bars, watchers, and we just add. And what we're gonna add is a new memory watcher. New memory watcher. And that is Boolean, and I'll explain what that means in a second. So a memory watcher can hold basically any data type. For example, Boolean, it can hold integer, it can hold float, double, etc. The only difference are strings, and string watchers look like this. String watcher, and without this, just like that. And the rest is the same. But for memory watcher itself, if it's not a string, if it's not text, it is just like this. There's just the data type. So if you wanted integer, it would be int or something like that. Also, with the string watcher, there would be the pointer, and then after that there will be, like, let's say 10. I see it in my code, so I typed 10, and that is how many letters it should read. But in case of memory watcher, that's not how it works. So inside of this goes another pointer. This time we know that it's a deep pointer. Deep pointer just means that it has multiple offsets. So we create a new deep pointer, and it's gonna take the instance pointer. So it's gonna so now we are basically at this point where we are just adding these things here. So we will not be adding the 0 because we already did that by doing this, because that's already like, because here here this pointer is basically this pointer, and we use this to read the next pointer. So this would be like adding this pointer, which you can see here, this address. It would be like adding it here. So we just skip this step essentially. So yeah, it's a bit more complicated. Yeah. So we add the instance pointer here, and we add the next offsets. So that's the C. Of course, it needs to be hexadecimal. So 0xC, and then we add the B9, which is 0xB9, and of course the memory watcher needs to be named in some way, which is kind of weird syntax for this, but it works like this. So we have to do name equals I call it finish load because that's what the value was actually called in the code, so I will call it this. So a bit difficult syntax, you have to look into this, how it looks. You're not going to be doing really anything more complex than this usually, so so that's like not that complicated. So here I will add some comments. This code will, by the way, will be available because it's like just better to see it in text form. So here create watcher list, read 4 bytes and convert them to 32-bit address. Create memory watcher and read the new pointer pass offsets. And name it as well, so and name it. So that's pretty much it for the initialization. And now this won't do anything for you because it only scans once, or it only creates the watcher and then it doesn't do anything. So very simple thing, you do update, and into the update you type watchers and update all inside of game. So this will update all of the memory watchers in this list. So this is the list of the watchers and we update all of them. And update occurs once every frame, so, or once every frame of live split, which is, I believe by default it's 60. So this will update this memory watcher all the time. And now we can just go for the loading. So we create isLoading as usual, and we will return. This will be a bit different. So we need, we can access the watchers. This is the watchers list, and because we added this memory watcher into the list and named it this, we just access the memory watchers, and as we did with settings in previous tutorials, we just access the finish load like this. So this is something you've already seen, and it looks, it has a bit different syntax from now on. It doesn't have like alt and current. Instead it has, I believe, current, alt, which is the same as you are used to, and then it has changed, which makes it a bit easier to watch the changes, and this just tells you true or false if it changed. So I will do current, and of course if the current is true, I want it to, that means the load has finished, so this is wrong. If it's false, which is done by this, then it should stop loading. So let's test it. I will open my split. Ideally you should just close the game anyway, but yeah. Let's take a look. Edit layout, control scriptable auto splitter. Let's see, I need desktop, and I hope this works. I will set game time here, which is already set, that's good. So now the timer is running while I'm in game, that's correct behavior. If I do restart, it stopped, and after the load finished, I can click the button, it resumes. So this seems like it works. Let's test it from the menu. Just to be sure. It has a little bit of delay, but that doesn't matter. You could activate it at any point in the load anyway, because it's the first one. Anyway, that kind of works. Now I will show you how the final splitter works, and I will show you how to also make functions. And why functions are important is because, well, they are not that important, but they are better for making the code a bit cleaner. So I will close this, and let's say you want to have multiple scans. I will actually put them here. I will just paste them from my actual auto splitter. These all work the same as the first one, and these are for, this one is for the load level name, which I showed you, and this one is for the running locker, which I showed you. Now this would be, I'll actually just give a note here, finish load, and this one is, I'll actually call it by the way it was called in the thing, but yeah, so this one was the loading screen manager, this one was game manager, and the last one is the first person controller, I believe. So that's it. And now you can imagine that you would have to do this for all of these three. Now that wouldn't really make sense, and it would, now when it comes to performance, you don't really care because it's at the start, so you don't need some complex algorithm, but you want it to look a bit more clean, so you create a function. So I will create a var, which might sound unusual. I will call it a scan, and a variable here can be also a function. So now the function will have basically several things. It will accept signature scan target. So we are here creating a signature scan target. So that will go into the function. Then we have the process, which is gonna be the game. It's always gonna be the game. And then we have int pointer, which is the value that it returns. The last one is the value it returns, this function. And now the syntax is a bit complicated. So we want these two to be named in some way, the signature scan target and the process. So I will call it target, and let's do G for the game. Let's keep it short. You can call it G if you want to. And then this arrow means a function, basically, like it's just the syntax. Don't forget the semicolon here. And now we type a function that we want to be made. So I will take this and there we go. We almost have it. We almost have it done. So we have the pointer, the 0 pointer. Now this will be the same, except here we just use the G because we will pass game into it and it will rename to C essentially. It will not rename, but it will have the name of G now. So here as well, the page doesn't change. And here, instead of scanning for any of these, we will scan for the target that we are sending to the function. And if it is found, then we can already actually just convert it to this, because why not? There's like no reason to just do that after it. It just is more code in lines. So it will return this pointer already converted to 32-bit address, and if after the for each it doesn't if during the for each it doesn't return anything here, it can return the pointer anyway. No, this is wrong. Oh no, that's fine, okay. It can return the pointer anywhere anyway, and it would be just in pointer 0 because that means it didn't find it. So we basically have the function that we had before, but now it's not, well, before it wasn't a function, it was just sequence of code. Now it actually is a function which we can reuse. So how we are gonna reuse it is, I'm gonna add a comment here, return no pointer if pointer wasn't found. So yeah, this is our function. And now we can use that, we can call it now. So we will again create the watchers list as usual. And this time we will I will add the command here instead. And return it. And here we will just use function for all scan targets, and it will look something like this. We will create instance pointer which will use the function. So we named the function vars.scan, so the vars needs to be there, by the way, scan, and we can use it as any other function. So we will add the scan target here. And the next is game. It accepts the process, which gets called G later, but in this context it's called game still. And we can just copy this 3 times, and that's just gonna be very easy. We call it instance pointer 2, instance pointer 3, and we scan for that targets nothing, 2 and 3. So these will be our pointers, and we can just create the memory watchers. So we already have this one, that's not a problem, and we can just create the other ones. So we will add another watcher like this. This time we are having the, I'm actually gonna call them, so this one is No, I'm not gonna do that. So this one is, you can actually see it in the line, so it doesn't matter. So this one will be StringWatcher because this is the load level name. So it's StringWatcher. It doesn't have these weird brackets this time. And it's gonna be, again, deep pointer. This time it's gonna be instance pointer 2. And it's gonna have a bit different offsets. Now, if you went to Mono, again, you could go to the class, which would be game manager, and fields, and we are looking for the load level manager, load level name. So that's 38. So we do 0x38. It's the pointer, because we have a StringWatcher, and we still need to add text here. In my experience, the load names were 10 characters long, so I will use that. And of course, don't forget semicolon, and I will call it as it is called in the code. So that is load level name. I'm also keeping the same caps, but it doesn't matter. You can call it whatever you want, really. And then I will add the final one, watchers add new, again that's memory watcher. It is a boolean, and again it's new deep pointer, this time instance pointer 3. And let's take a look. So Dissect Mono. Let's find the class. So the class is called first person controller. First person controller. I hope. It found some weird one. This is not it. No, well, maybe this is the one actually. I would have to look at. Yeah, it's inside of Smart FPC controller and first person controller. So it was actually not in the assembly file. That's fine. We are using something else, but that's completely valid as well. And we are looking for running locker. That's an interesting value. Run. Where is the running locker? Is it just called locker? I don't think so. I think it was actually running locker. Yeah, here. So here we have the running locker, and that's DO. So again, we add in hexadecimal DO. 0, by the way, not O as in the letter or the character. And we will call it again as it is in the code. So that's the running locker. And this will be pretty much it. So these are the values. And we can, so the thing I did after all was the following. I added this here because the problem was that there were some situations where there was not a load, but there was like, you were stuck, you couldn't move, and that time was inconsistent between players, and sometimes the game even got stuck at those places. So we just check for the running locker, because if we are not able to move, then it doesn't really make sense to not remove loads. It just makes sense to remove them in that case if it's inconsistent for people. Of course, this doesn't apply to every game. In some games there might be skips where this would actually be harmful to the people who do the skips. So there, of course, think about the context. So we are going to use the running locker. We can even copy it, and we check for the current one. So this means if the finish load is false, then it will be removing loads. or if the running locker is false, then it's also removing the loads. And we can also do the splitting, and that is very similar. We check for the watches, we check for the load level name like this, and we just can use the changed, because this will tell us whether the value changed or not. This is a bit easier than doing like return old load level name is different from current load level name. You can see this is a bit longer, a bit more tedious, so this is pretty handy, but we cannot use this because these are not the addresses that we defined in state, so we have to use this, and it's a bit easier to work with as well. So yeah, I will just add a little bit of comment here. If load level name changes, split. If finish load is active, is true, or false, remove loads, or remove, or if running locker is false, remove loads. So that's pretty much it. And I will just finish. I will just finish these comments, and I will share this code with you so that you can easily look at it. And I hope this kind of explained you how to make auto splitters for Unity games. It is a very long tutorial, but as you have seen, we did just one scan. So for some people this might be a bit more comfortable looking for the values. I'm pretty sure this is possible for other engines as well. But the signature scanning is very important because you might, in some games, you might also use this because there are situations where the game just has inconsistent memory, just as Unity, and it will just be problematic. So you can use the signature scan and make this a bit better. So this also is very good for versions, because sometimes if you wanted to make multiple versions of a run, you would like have to do something like this, make multiple states and put the version name here. But you also have to, inside of init, you would have to basically add some logic that determines what version the game is. There are multiple ways to do this. Just look at Fatalist's website, and he has a lot of auto splitters here that you can look through. I will actually probably do it for you. So Fatalist pw /livesplit/ASL list. Also, don't get baited by just typing fatalist.pw. That's not a good thing. It's a nice meme though. Anyway, you can take a look at detect versions in behavior, and for example I will click this, and in init you can see that, for example, here module memory size is being used to determine what version it is. Let's take a look at another one. Let's take a look at something more complex, like Amnesia. It has signature scans, I believe, so that's a bit harder. Let's take a look, and that's again some size. There's multiple ways, and you can try multiple things. I can show you my Diablo2 auto splitter. That one is really easy thing. So the modules first has a file version info, and the file version you can actually print it into debug view, and then you can just see that one version has this, one version has this, etc. So there's multiple ways how to determine the versions, but with signature scans, you just need to do this once, and it will work for all the versions and all the future versions of the game. That's not always the rule, but if you expect many updates, I recommend you to try signature scanning, because that might help you get these a bit more consistent, and you won't have to update the autosplitter every patch. Some games have like weekly or monthly patches, so that might be painful, especially if you leave the community and they don't have a way to fix the autosplitters. Now, there's usually a way to play the older version of the game, but that's also a bit of a mess for some people, so it's always better to like have either consistently updated autosplitter or just do a signature scan if you don't want to bother with updating it. But it still might break at some point, because there might be a bigger patch. So I will put this into the description of the tutorial, and for me for now that's all from me. I'm not planning any more tutorials, or I don't have any idea what I could cover right now, but if you have any questions, I will definitely make a video based on that. That's totally possible. So see you. Bye.